Alright, wiring diagram for the Mastodon. Flywheels, pusher, battery, firing trigger, and rev trigger micro switches. So we have the positive and negative of the flywheels, the positive and negative of the pusher, positive and negative of the battery, normally closed, normally open, and common, common, normally open. The normally closed tab is not there because you do not use that on the rev trigger micro switch. Okay, flywheels, positive comes down and around and comes into your common of your rev trigger. Normally open comes up here and goes to the positive of your battery. The common of the rev trigger comes to the firing control switch and into the normally open tab. From your common of the firing trigger, you come around and go to the positive of your pusher. Now, those are all positive lines. Your negative is connected to the normally closed. It goes from the negative from the battery to the normally closed tab on your firing trigger, and then another one comes off the normally closed and goes to the negative on the pusher, and then continues on to the negative of the flywheels. Those are your only negative lines. So hopefully that helps you out a little bit. If you have any questions, obviously leave them in the comments below and I'll try to help. I just did this connection down here, and this is the red wire coming from the flywheels. The positive of the flywheels comes into this, which is the common, and then this blue wire is coming off, and it's going to go, it's not connected to anything now, but it's going to go into the trigger control switch up here. That is a 2-prong connection. Just make sure you have that shrink wrap around both wires and out of the way before you connect this, and then you can kind of seal that up there with some shrink wrap. Alright, now I'm going to put this connection on, and this will go into the normally opened, and this comes from the battery. Okay, so I've added that wire, and now you can actually test and make sure your flywheels are working. So I just use a little 9-volt here for test. You don't want to test with a LiPo, so we'll go ahead and test it out and see if it works. Seems to be working pretty well there. There might be an issue with this motor, but if there is, let's hope there isn't, but it doesn't seem to be fully going at times, which makes me nervous. Okay guys, I just wanted to give you a quick look, and I don't know if you can tell there, but I've carved away a ton of the other half of the shell to get that micro switch to fit, so this will sit down properly, and I just wanted to show you that where I kind of carved out to get mine to fit. Obviously, depending on where you place your micro switch, everything's going to be a little different, but this is what I did for mine. It's not pretty, but it closes. So I have my plate epoxied and it's cured now, so I'm ready to place my micro switch here. And I would, just so you guys know, I did keep this plate here. I didn't grind this out, so this has something to push against. I think that's kind of important because I feel like if you got rid of this part and you just used the switch, it may be a little bit too easy to pull. I don't know, I guess it's personal preference on what you like, but once you cut it, you can't go back. So make sure you keep this tab here and this to have it so it has something to spring against. We're just gonna see where this needs to go, and I think there looks good. And I'm gonna keep that roller on this one because I think I like how it just rolls along there. I feel like that works pretty well. This is actually rosin flux, which kind of helps the solder flow into the wires a little better. So we're gonna connect this to the normally open tab here. This is the blue wire that's coming from your common on the rev switch. Make sure you have your shrink wrap on before you make this connection, and any other connection for that matter. And then we're just gonna use a little lighter here to shrink that up if you guys don't know how to use shrink wrap. Just be careful when obviously using the flame. It's a little hard to get to, but just like that. Okay, I just made this connection. This is the common, And it could be, I used a red one because like a dummy I have a blue one over here for my negative, which should be black, but like I said, I didn't have any black. Actually, I just found some black, but didn't have any black when I did that. And then we are gonna take this. This is gonna go to, this comes from the common, and it's gonna go to the positive, which is the front terminal on your pusher motor. All right, guys, so I'm about ready to make this double connection here. So I did find some black wire, and I'm gonna use blue for the other one, just so they're different. The black wire here is going to, this is the normally closed, it's gonna go to the battery tray. The blue wire is gonna go to the negative on your pusher motor. So that's a double connection. That's a little tough. Make sure you have your shrink wrap and a good thick piece of it around both wires before you make that connection. And then once you make that connection, you can, go ahead and move your shrink wrap down and lock that in. Handy hands, very, very important to get a good connection. Okay, so I just made this connection, and this is the blue wire that I connected to the normally closed. Comes up here to the negative of the pusher, and then also the negative from the flywheels connects to there. So that should be everything, and now we just need to connect your connector of choice. I use, my LiPos use XT60 connectors, so I'll be putting one of those on the end of here, and then we'll test the circuit. Alright, I hooked up my 9-volt again here, and I wanted to test this before I connected a LiPo to it, make sure everything seems to be working. And if you, the flywheels go there, and then seems to be working. Alright, I just dremeled out a little bit up here, didn't really take actually that much to make this fit, and yeah, I think we're good. We're just gonna have to put it all back together, and hopefully we don't forget anything in that process, and we'll see if it works. After you get everything back in place, don't forget to lock down your internals. Putting the screws back, I've already got 3 of them in. I'll put this last one. These are smalls that go in the motor cage. And I think we got everything in here, hopefully. And now we'll put the top back on and put in the zillion screws that go in the top. Alright, so I want to keep the jam door in place, so I'm going to go ahead and super glue this back in here. It's not going to be connected to anything, but that will just keep it from, when it's open, I think it'll keep it held that way. Alright guys, so I just wanted to be completely honest with you, and I really have no explanation why this happened, but one of my motors, when I was testing polarity of direction with a 9-volt battery, basically just kind of stopped and just went really slow, and then now basically isn't doing anything. I went ahead and did the mod guide as I would, and rewired the whole thing with these 2 motors as if they did both work, and hoping that maybe it would work when I had it rewired, but it has not. So I am going to try to source 2 new motors, because obviously they have to be the same. So just be very careful when testing your motors, and obviously removing the board from these motors. Be careful there. I don't think I messed it up there, because it seemed to work initially when I had hooked it up to the 9-volt. Obviously modding, and these are some of the risks you take when modding your blaster. Okay guys, I'm going to show you how to get flywheels off out of the Mastodon, and this will probably work for pretty much, or a similar technique should work for any sort of cage that doesn't have a way to use the trick like in most standard Nerf cages, where you can take 2 screwdrivers and put them up through the holes, because we have no holes to go through here. I know a lot of other people use 2 and they pry on each side and try to pull it up, but the way this cage is made, and this is a very flimsy kind of cage too, so I wouldn't want to put a whole lot of pressure on this cage, and there's really only one side accessible to the bottom of the flywheel cage. So how are we going to get this off? Well, either use some duct tape or gaffer's tape would be better, but I have no idea where mine is, and that's very expensive stuff and hard to get. So more people are probably going to have duct tape. And you're going to need quite a bit. So I'm going to take a piece about like that, and then you're going to wrap it around here. Hopefully I can do this and show you guys at the same time. So I'm going to wrap it on around the side like this, and just keep wrapping it around as much as you can. There you go. And then you're going to crimp it down in the middle and try to get it down in the middle like that. So you have a little tab in the middle. It doesn't have to be pretty. You just want to have good adhesion to the sides as much as you can. So just kind of make sure it's all there. And then you're going to take a pair of vice grips. Make sure it's in the right position so you can get a good clamp on it. And then you're going to pull. You're going to try to pull straight out. And there you go. Now, I did not really come up with this idea. One of my good friends, Fisco Bandito, did this with a Snickers cage to get the flywheels off a Snickers cage. But this was my first time trying it, and it works really well. Okay, guys, so this is my solution on how to replace motors in your Mastodon. These are MTB Hellcats. It's a 3S 180 motor. And what I've done to make it fit is this is a piece of PVC. It's I think it's 3/4 PVC, but this is actually the coupler end. So when you get a long piece of PVC, there's a part that that's wider, so the other part of PVC can go inside of it. So this is the bigger part, if this makes any sense, and if it doesn't, I apologize, but it's the coupler part of the end of the piece of PVC. So I cut that off, cut it in half, and then I had to kind of cone the edge of it so it would slide down in there nicely. It's just a tad big, so I just coned the end of it and then pushed it down in. And so it is sitting, it's about as you can see there, it's kind of ground down a little bit. It's just a little bit past the end where this sits. So it just goes a little bit past that point. And then I took PVC, the other part that's 3/4 PVC, and made shims to slide down on each side of this. And then I cut them short, so then hopefully we'll still have, because these have air holes in the side. So I don't know how much air is going to be able to get in there, but I didn't want to block that off completely. So I cut them down just a little bit short, so they're sitting just below those holes in the motors. So you did that, and then you do this to keep it stable. So when this is moving, this is stable. I didn't want to do like some E-tape and just wrap it around there, because the motors will get hot and that will melt, and that will not work out very well. All right, guys, it's done. There was a little bit of troubleshooting. I had a little bit of an issue there with obviously the motor, but I think I have that fixed now. Threw some 180s in there, and it seems to be working pretty well. I'll have to play with it quite a bit just to see how well it works, but it seems to be working pretty well. Pretty loud. And a pretty darn good rate of fire, obviously. I wouldn't want the rate of fire any more than that. That is definitely fine. And obviously it's still easy to single shot. It is much louder now, but it is a beast, which it should be considering it's a Mastodon. So hope you enjoyed this mod guide, and thanks for watching. Peace out.